Hi Jade. So this video is for you. So you were asking me about these three questions. So in the sequence 10, 7, 4, etc., what term has value of this? In the sequence 2, 6, 10, 14, what n corresponds to this? And finally, if A24 is 85 and if A28 is 100, what is A1? I'm going to tell you right away that number 3 is very, very similar to number 2. So I will help you out for number 2, but I will probably expect you to do number 3 using the same type of technique. And I'll help you for number 5 as well. So let's have a look at number 2. So the idea behind, these are all arithmetic sequence, by the way. So you could probably review what you have seen in class concerning arithmetic sequence. But still, I will give you the general idea of it. Okay, so here we have like 10, 7, then 4, and then you can probably guess a couple of terms, like you will have like 1, you will have -3, and this is because each of them make a bounce of -3, right? So you have here A1, A2, A3, A4, A5, and so on. And what you need to realize is that to go from A1 to A2, you're doing like -3, then -3, then -3, and so on. Okay. So let's actually write a formula that will work for 1, 2, 3, 4, 5 maybe, and then we will have a look at how to deduce the formula. So all right, A1 is 10. Okay. Then A2, as you can see, it's going to be 10 and then -3. Okay, so I will just say here -3. Okay. Then A3, look at this carefully. You're gonna have 10, and then you're gonna subtract twice -3, right? So one thing I will write here is +2 times -3. Okay. And then to get to A4, okay, you will have 10, and then you are, to get to A4, you are subtracting 3 times 3, right? So in other words, you're adding 3 times the -3. Okay? Okay, why do I do this? It's because actually from here it should be like simple enough to identify the pattern. So for example, here you need to add once the -3, right? So if we actually write it in the same way as we wrote these, so +1 times -3, and okay, here I'm gonna do something funny. I'm gonna say here +0 times -3. You might be wondering why I'm doing this, but it's really so that I can identify my pattern well. And now what you need to recognize is that this number here is always 1 less than the number here, right? So I have 3 here, this is 2. I have 4, this is 3. So in other words, you should be able to guess a pattern for the, well, not only guess, like pretty much deduce a pattern for the nth term, okay? So to get from 1 to n, you start at A1 and you add n-1 times. So n-1 times the bounce, which is the -3. Okay? This is the general setup. Okay, so for an arithmetic sequence, you will always start. So this is your A1, by the way. So you probably recognize it here. It's your A1. And this, let's just say it's like the bounce. Okay, so you have like a constant bounce. And this formula will always give you the formula for an arithmetic sequence, like a sequence for which the bounce like this is constant. And now what we want to do is we want to use it to find which term has this value. So the way the problem is asked, it asks us to find the value of n. So we want to find the value of n for which AN is equal to that negative 296. Okay? Now we have a formula for AN. AN is written over here. Well, we could simplify it a little bit, right? One thing we can say, for instance, is, okay, now that we have this is the same thing as writing, we're going to distribute the negative 3. So we're going to have, let's say, negative 3 times N minus 3 times negative 1. Okay, so you could simplify it a little bit just so that answering this question is slightly easier. And as you can see, simplifying that, so 10 plus 3, 13, you get 13 minus 3n. Okay, all right, now that we have this set up, let's answer this question. So we replace an by this formula. So we have 13 minus 3n is equal to negative 296. And from this point, it becomes just regular algebra. So send the 13 on the other side, you get negative 3n, which is equal to, now mental math is not really my best suit, but I believe it's going to give negative 309. Yeah, we're good. And then, of course, divide both sides by negative 3. You're getting 103. All right, so this is what term has value. So the 103rd term has value negative 296. So this is for number 2. Now, as you can see, we found a value of n, right? So this is the answer to number 2. But what I want you to see is that what we found is actually the value of n, for which we have an equals negative 296. So even if these two questions look very different, they actually are the same thing. So I would like you to solve number 3, having this in mind, right? So try to use the same technique. Try to use this example as some kind of placement to solve the problem number 3. Okay, now let's talk about number 5. Okay, so number 5, now we need a more general formula than this. So what we're going to do is I'm going to erase all of this. And we're just going to do a very general setup. Okay, so we will have a sequence that starts at A1. Okay, and then we will have A1 plus B. Then, as you can see, we will have like A1 plus 2B. So A1 plus 2B. So, and actually, I'm going to just do the same thing as I did before. Okay. Then A1 plus 3B. So in other words, I'm writing an arithmetic sequence in its most general form. So what I want you to recognize is that we're doing bounds of B every time. So we're adding B, and adding B. And we continue like this forever, right? And this is A1, but obviously this is A2, this is A3, this is A4, and so on. So from there, we can get that for any arithmetic sequence. So AN will be equal to A1, so the same A1 that I have in every term. And then, again, I need to add n minus 1 times b, because you need to make the correspondence, right? You need to see here that for A3, we're adding 2b. For A4, we're adding 3b. So from there, okay, we know that in order to get to an, we add n minus 1 times the value of the bounds, which is b. Okay, now that we have that, the idea is to replace 28 and 24 in these formulas. Okay, so what is going to happen? We have A24, which we can directly write here. A1 plus, so it's going to be 23 times B. And then we know that this is equal to 85. Then we have A28, which is again A1, but now we need to add 27 times the bounds. And we know that this is equal to 100 in this case. So what's happening is we have a system of two equations in two variables. Okay, so let's just focus on this system now. We have like A1 plus 23B is equal to 85. And then A1 plus 27B is equal to 100. I would like you to compare this to something that you might have seen before. X plus 23y is equal to 85. And then x plus 27y is equal to 100. So you probably have learned how to solve these types of systems. And the best way of doing it, so I'm actually going to solve this system right here. So you have A1 plus 23. I'm actually going to copy the second one first, okay? So A1 plus 27, B is equal to 100. And the second one, what I do is I swap the signs, right? I'm going to turn it all into negative. So I'm going to have here negative A1 minus 23B is equal to negative 85. This is just in order to cancel the A1 because if you remember, the next step is simply to add these equations up. Okay, so you cancel the A1, then you do the addition over here, and we're getting, as I can see, 4B. So 4B is equal to what? Well, it's going to be equal to, so 100 minus 85, so that's going to give us 15. Okay. Now that's a little bit funny. Like I wouldn't have expected this because as I can see, the bounce is a fraction, so 15 over 4. Okay, so I'll just have a quick look if I have a mistake somewhere. So this setup is the general term, so this I do not mess up. We don't know what is A1. This is actually what we want to look for, right? And then, okay, so 23, 27, yeah, they are 4 apart, so that totally makes sense. And they are different by 15. Okay, so I didn't mess up. I know that my bounce is 15 over 4. Now from there, what you want to do is simply to replace B in one of these two equations. So meaning, for example, that I will replace it in my first equation here. So you have A1 plus 23 times the value of B that we found right here, right? So whatever you found here, this is your value of B. You put in here, so that will be your 15 over 4. And that has to be equal to 85. All right, now I'm going to erase this and just continue the solving for A1. So as you can see, there's not much to do. We just send you just send this on the other side. And now, I don't know if you are allowed a calculator or not, but note that in order to subtract these, like you need to use a common denominator, right? So you have like multiply by 4 over 4. Then this is going to give you 23 times 15, 15 over the 4 that you already have. So what you have to do is to subtract the numerators. So I do need the calculator for that. So I'm just going to use like this guy right here. So 85 times 4 minus 23 times 15. So that gives you negative 5 overall. I probably could have tried to do it in my head, but I just didn't want to waste your time. So This is it, man. Good. This is the value of A1, right? So A1 is equal to -5/4. All right. I hope this helps. So give me feedback and have a good one.